Then comes traversal zones. Now, all the topologies that we have discussed have been achieved using neighbor zones prior to this to connect the Expressway C servers together and route calls between them. There are three other zone types that can be created on the Expressway servers. The traversal zones, which are used to route calls between Expressway C and Expressway E. Those are called traversal zones because they passes through the firewall. Expressway C is a traversal client and E is traversal server. Right? So for the calls like business to business communication or to Cisco Collaboration Cloud or third party like Office 365, we have to go via the traversal zone. Then there is something called unified communication zone, which are used to enable devices outside of the corporate firewall to register to the CUCM inside of the firewall. So let's suppose the outside device does not directly wants to get registered on the Expressway and the inside, but any other product. For example, here CUCM. So in that case, a unified communication zone is created. Yeah, so request comes to Expressway E. Expressway E will then connect it to Expressway C, and Expressway C will forward the request to CUCM here. Yeah, so this is called a mobile and remote access. So inside the firewall, this mobile and remote access registration of the mobile devices, remote devices is done. So that is unified communication zone. This is default zone. Again, now default zone is the one that connects the expressway with the outside network. So this is the final zone type that is a permanent one and cannot be deleted in the default zone when you have a connection with any other network. And obviously, if you are using expressways, that is a purpose where you will be connected to outside network. So the default zone is used to capture the calls which are coming from or going to an unknown place. Unknown place means outside of your enterprise. So it is used to capture the calls to and from the unknown places. So this was about the zones. Next, we will discuss about digit strip manipulation. That is another topic. So digit strip manipulation can help you manipulate things like alias, dialed strings, which we use in as a part of dial plan. So for that, we use it to match your dial plan. So you can manipulate alias or strings to match. For example, if let's suppose any request comes from 1001 and goes to a destination 1002, and it has to be translated to 1002 at the rate cisco.com, for example. Yeah. So any alias or dial string manipulation, that all can be done with the help of digit string manipulation. There are different ways and processes used that we will discuss here. So when you need to append the domain name or strip the domain name, appending domain means just adding a domain name, or stripping a domain name, or make a complex change, for example, like completely changing the dial string. So that is a high level manipulation that is done in the digit strings. So you can use different tools for it to manipulate digit strings. We have ways like we can create pattern types in exact, prefix, suffix, regular expressions, all of that. Yeah. So when the Expressway has options to manipulate these digit strings for local calls or calls to remote destinations or remote call processing system destinations, so we can create these things called transforms in which we can create priority for each transform. We can indicate the state to on or off. We can define description, which is optional. We can create a replace string if you want to change the alias or the dial string pattern. We can use pattern types as these. Pattern string can specify the pattern against which areas will be compared. So like the incoming request and the outcome. Then the pattern behavior, whether you want to strip any particular string or you want to replace it or add any prefix or add any suffix. All that can be done in digit manipulation. So when a call setup request comes to Expressway, there is a pre-search transform which is tried as a part of the process. So whenever call setup request comes in, write it here. there will be a pre-search transform. Now, not in all cases it would have it, but if you have any transform, then it will first look for the transform and tries to find a match to transform the alias. The location is the first that allows the alias transform. If no transform is matched, then the call setup request continues with its normal process with the regular call processing process, which I will explain what is the exact process. Then we've discussed about the pattern type. So up to, first of all, the research transforms up to 100 per expressway can be created. This is the number of research transforms that can be configured within an expressway. Each transform must have a unique priority value, and the priority range is 1 to 65534. This is the range of priority values we can assign, and it is uh, important to define a unique priority to each transform so that the routing can take place properly and the manipulation based on the performance, on the preference here. So you need to first specify the pattern string which the alias is compared against. So for example, any domain like example.com. Then you need to specify a pattern type. So pattern type would be exact, prefix, suffix, or regex. So exact prefix matches the entire string exactly, character by character. So for example, if the pattern string is anything like any name at the rate any domain.com. Yeah, just as an example. And we want to just exactly match it, we can use exact pattern type for that case, all the strings, name as well as the domain. Whereas we can use prefix, so this pattern type matches if the beginning of the string matches the alias. So for example, if the pattern string is any name as a prefix, yeah, and we want to match if the prefix is this, then what should be the action? We can, in actions, we can either strip, replace, add prefix, add suffix, and all of that actions can be taken. Suffix, as the name says, is the end of the string. Yeah, so for example, if the pattern string is domain.com that we want to match, as we are using suffix, then the alias must end with that particular domain to match that pattern. Regular expressions are used for more complex string types and manipulations. So if a pattern, for example, for regex, we do that in more detail. But just as an example here, there is a regular expression we have configured this. This is anything, any number of string numbers or any string. It can be alphanumeric, anything ending with any domain, example.com. Yeah. Then the alias must end with the example.com. This just says anything that begins with any string, any number of numbers or characters to match this type of pattern. So then we have different regular expressions which are used, like there is a dot used for a single character, uh, \d for numeric characters that we will discuss more in the topic we have specifically for regular expressions. But yeah, this is what digit manipulation is. So once you have specified the pattern type, after that, you need to specify the pattern behavior that will determine how the alias is modified. And the pattern behavior are these. We have strip, replace, add prefix, add suffix. So like strip, this will remove the matching prefix or a suffix from an alias. And you can use this pattern behavior when you want to make calls from, for example, SIP to HT23 that do not use the alias with the domain name. So you can do a strip there and remove the domain name when the call is going from SIP to HTTP3. And in the opposite case, you can add or like add suffix in that case and add a domain. Then we have replace. Replace will replace the match string, the alias that you have to find in the pattern that you want to match. Once it is matched, then you can replace it. For example, if you want to replace domain.com with cisco.com. So if the matched pattern is domain.com, it should be replaced with cisco.com. So that is replaced. Then add prefix. This will prepend the replace string to the alias. So you can use this behavior when you want to add any additional numbers to a string or dial string. Let's suppose the request comes for a local number 1001, and you want to add something like +120,120 and then 1000 to make it this originally. So you want to add some prefix, or if you want to add some suffix, yeah, which is usually used in the case of calls from HTTP3 to SIP, like I said. So as the SIP endpoints works with the URIs, so endpoints when HTTP3 are making calls to SIP, we can add a suffix with the domain to make that call work. So this is about it. The next is search rule. In the search rule defines how the expressway route calls to the zones and therefore to the destinations, such as CUCM or other expressway or a meeting server and so on. So that defines the search rule, how the calls will be routed to the zones, to the different zones, therefore to the destinations. Those destinations can be different parts of the network, can be any other expressway or another CUCM or another device like a meeting server. So when a call reaches an expressway, it has to locate the dialed device as a normal lookup process. The expressway will then locate the device using the search rule that defines where it should go to find that device. The search rule follows a logical sequence to determine the location to search and the order in which to search them. So it will check for which zone do I want to search, under what circumstances should I search that zone, and what order should I search that zone? Which zone, what are the conditions, and what is the order? These are the things that a search rule contains. So all search rules have a priority, a search pattern, and a location that determines which zone is searched, under what is the condition to be searched, and in what order it is searched. So first, there is a local zone in Expressway itself, which is used to search, and it will look for the locally registered device. That is always the first preference by default. The Expressway has a high priority search rule defined to a local zone automatically for any address that has been dialed. This search rule can be modified to only search the local zone under certain conditions. Let's suppose we do not want Expressway to always search for the local zone, but we want to change its priority and give it a lesser priority and search other zones for it. Let's suppose for traversal calls, we want to give preference to traversal zone in that case. So, but by default, Expressway will search its local zone for all addresses dialed. You can create your own search rules to prioritize the search on the devices using the other zones. So here is an example. So in this example, there is an Expressway C with three zones. There is a neighbor zone to CUCM, a neighbor zone to another expressway, and a traversal zone to Expressway E. So you have a structured dial plan here where all IP phones and uh, CUCM have a directory number that is prefixed with a number 3. Yeah. And all devices that are registered to Expressway C have a domain of example.com, suppose, on CUCM, on the Expressway C, let's suppose. Yeah. So in this table, we can see right here, for the search tool to work, there are some values which are being used. So there are main 5 columns. We can see search priority, there is mode, pattern type, pattern, and target. So search priority defines the order in which the rules will be executed. So it's like the order of the processing of the rules. So it should be carefully defined when you're using priority value. So as per the preference, we give the priority and it will always go in a sequential manner based on the priority value. So it will define the order in which the rules will be processed. So when the pattern matches the dialed address, it will then stop processing the further rules. So the lower the number, the higher is the priority. So that is how it is even written here. And in the table, it is designed in that way. So lower is the number, higher is the priority. Yeah. So the priority is in this order. The lower priority goes at the end. Okay. So priority 1 is executed before 65536, which is the maximum we can configure. So these are the order of the rules to be processed. Then there is mode, which defines whether the rule applies to all the searched areas which are dialed, or whether only to the dialed areas that match the defined pattern. There are also a mode for IP addresses, which is not covered here, but here we are using mode types like any alias or any pattern match as per the alias. Yeah. Then we have pattern type, which defines what type of pattern the dialed alias must match with. And there are four pattern types, as we discussed: exact, prefix, suffix, and regular expressions. Exact, which means the complete dial string will be matched. Prefix, the prefix will be matched. In suffix, it means the dial alias, especially like the domain, would be matched. In regular expressions, it is like more flexible, more granular way of the manipulation, and it allows you to match certain part of the dialed alias and do more manipulation, which is focused in a different section. We will talk about that. Then pattern will define the value that the dialed alias must match based on the value in the pattern type field. And lastly, there is target, which defines the zone that will be searched if the pattern is matched. So which zone it should finally go to. So you have four search rules here with different priorities. We have priorities 50, 100, 200, and 300. The first rule with the highest priority is the search of the expressway local zone with a mode of any areas, which means that the local zone will be searched first, regardless of which areas will be dialed. Then if the search fails there and the dialed alias has a prefix of 3, that is the next rule. Then the neighbor zone to the CUCM will be searched. Yeah. So as per the target, you can see CUCM neighbor zone is searched in that case. If the search fails there and the dial alias has a suffix of @example.com, like here, like suppose, yeah, example.com, then the neighbor zone to the expressway C will be searched. And finally, if all other searches fails above that, the expressway E will be searched to see if it can locate the device using the traversal zone. So you can see it is going in this sequence. So priority is like the order here. The lesser the priority number, higher is the preference. And the processing and the search happens in the order of the ascending order of here, like based on the priority. And as soon as the match is found, it will take the action and send it to the target. If the match is not found, finally it will be then discarded. So this is the order we can see here. So search rules can be configured to continue or stop searching for an alternate match once the prioritized search rule can be matched, but the destination was not reachable or it was not found. You can control the search behavior on the successful match, that what should happen once the match is found, to either continue searching or to stop it. Some use cases are like if you want Expressway to continue searching after successful match, to configure a redundancy or an alternate path for the call. So you will set search rule with on successful match parameter to set continue, which is not very commonly used, but we can use it. So in case where Expressway will continue searching for another match search rule with lower priority, so if you want to use only one path to remote destination and not try any alternate path search, you can set the unsuccessful match parameter to stop searching at that point. Yeah, that was it. This is the same example. So that is for the failover. So where if a successful match is found, then we can either set it to continue or to stop searching. Then comes transforms. So transforms are the ways we can make the changes to the alias or the dial string. So these are the first thing that the Expressway performs when it receives a call request. So when a call arrives at Expressway from a directly registered device or via a zone from another device on the CUCM network, its action is to determine if it needs to perform a transform. So before this, everything is done like the search rule and everything is found, and finally it reaches its target zone. Once it reaches a target zone, then the expressway will have to perform any transforms if they are configured. Yeah, so it will look for any transforms there, and based on the transform configured, it will take the action. So a transform will allow an incoming dialed alias to be changed to something else as per the transform we have configured. So Expressway does not allow a transform to be performed on the dialed addresses, only the dialed alias. That is something about transforms. And alias can be useful when redirecting calls. If a user, for example, leaves an organization and their calls needs to be rerouted to another user, then a transform can be created to change the dialed alias without changing it for the customer. So they will be using the same alias, but then it is changed to another alias by the Expressway and it will be sent to another user. So there are things like amend incorrect domain. So this is an example where a transform can be used if someone dials an address with an incorrect domain. So for example, suppose a user dials john at the rate example.com, if we can see here on the screen, but the domain should be cisco.com. So instead of rejecting that call, we want that the user should be translated and find the correct address and redial it. A transform can be created to change that. So let's suppose we know that earlier we were using example.com as a domain. So we do not want to lose those important information from customers, and we want it to be translated to a new domain, cisco.com. We can do amend incorrect domain. Then we have correct domains from CUCM, which is a very practical situation where a transform is required in Expressway. Is when a call is made from, let's suppose, CUCM to Expressway via a SIP trunk or neighbor zone. The callback address that is received from the CUCM is presented as a number, then at the rate either the IP address or the FQDN of it. So for Expressway to locate that device in its search, it has to replace the IP address and the port with the domain address of Expressway. To accomplish this task, it creates a transform so that when the call arrives from the CUCM, the dialed alias is transformed with the correct domain and the search can proceed. So these are different ways we can do the transforms. Then we have some transform settings. So with this example, it shows the three transforms are there for the scenarios that were that we discussed earlier. So the first transform shows how to direct a call from one alias to another. The second shows how to correct an incorrectly dialed domain, and the third shows how to replace the CUCM IP address domain on an incoming call to use the Expressway domain. So here also there are some basic settings configured like priority, pattern type, pattern string, pattern behavior, and replace string. So first is priority. This setting is the priority of the transform between 1 to 65536, which is the range of the priority value that we can assign, with lower number being the higher priority. That is something to note. Then a pattern type is the part of the incoming alias that the pattern string must match for the transform to be applied. Then string is the pattern against which the alias will be compared. And behavior defines how the incoming alias will be modified. And replace string is the setting, is the value to use to replace the selected part of the incoming alias. That is it about transforms as well. So these are the different ways and components which are used for the call processing in Expressway. We have talked about zones, subzones here, digit manipulation, search rules, and transforms. Next, we will see call search history and registration. Before we get into this lab, this is something I would like you to know, that in call search history and registration, we are going to look through the Expressway call search history and registration and take a look at launching alarms. Before that, we first we'll do is registration. We'll register calls, the endpoints. Once registration is done, then we'll do call search history by making calls. So before we jump into the lab, I want to talk about just a moment for as a quick review of how Expressway processes the inbound call setup here. So when Expressway receives a call setup request, so here we can see in a nutshell as a summary what we have discussed in detail. The first thing it does is it looks through the transforms. Yeah, we have discussed in the order of how we configure it in the Expressway, and now we are seeing how Expressway processes the calls. So a call setup request comes in. The first thing it will do is it will look through the transforms to find a match. If it finds a match, that will allow Expressway to modify the destination address so that it can successfully find a target. After having passed through the transform, the Expressway will now take the original called in party and the new called party and pass that through the admin policy. So first it will look for a transform. Based on the transform, it will do the modification. Then it will look for any admin policy to check if the party A, let's suppose, is allowed to call party B, if there is any deny policy, or if there is any allow policy in which this destination does not coincide. So if there is a time of day restriction also, that is another type of admin policy. So admin policies can be built in either in the Expressway itself. We will see how we can create those. And other than that, we have another way of using CPL scripts for like more detailed policies if we want to create. That's a part of like if we want to do any scripting and create more advanced and detailed policies. Now, if admin policy allows the call, let's suppose in this example, then it will go to the find me configuration to see if there is a match there. Now, find me will allow single target alias to represent multiple actual target devices. That is when you have redundant paths is used. If that is not the case, then it will skip this path and just it will not find anything here and it will go to the next, that is the search. So then it will search locally, and we are not looking at the redundancy here, so no find me will be found here. And then it will go to the next step that will look at the actual call search history. So Expressway will then look for a match for the targeted address and try to ring that device, and it will ring the targeted device. So this is how the call search happens in the Expressway. So